Hello again. Now we're going to look at solving for the linear speed given the angular speed and radius, but also converting using double unit conversions to particular end units. Now, if you're following along with the handout, the previous video I talked about the general information that's on the front. Now, in this one, if you go to the second page, it says problem type 1. Radius of circular or spherical object given in RPMs. Find the linear speed of a point on the circumference of the object, etc. Basically, I'm going to jump right to, I work out this problem for you on paper, but I'm going to work out the second one here for you on the video. So really what is number 1 on your handout is what I'm going to do right now. But if we read the problem, it says if a 12-inch circular saw blade, that is a 6-inch radius, is rotating at 2,000 RPM, what is the linear speed of the blade tip in feet per second and in miles per hour? So basically we have to find the linear speed, v, given certain information, and then put it in certain units. So we start off, we have a radius of 6 inches. We have an angular speed of 2,000 RPMs. RPM automatically, boom, you should think spinning, that's an angular speed. We're looking for a linear speed, v. So naturally we're going to want to use the v equals 6.28 times omega times r formula set to solve for v. So when we do that, that is v equals 6.28. Now the unit that goes with this is radians per revolution. And that's important because I want you to write your units out to see what cancels out. This is 2,000 revolutions per minute times our 6 inches. So really, notice we're just multiplying 3 numbers. So we're taking 6.28 times 2,000 times 6, and we end up with 75,360. That's easy. Now the units, if you notice, revs are on bottom here and they're up top there. So revolutions cancel out. In our linear unit, radians are assumed, but they're not written. We do not write them as part of the end unit. So notice we have minutes on the bottom of this conversion factor, and inches, if you think about that being over 1, is up top. So our end unit is going to be inches per minute. That's our unit for our first answer. So when we plug into the formula, automatically we're going to get, in this case, a linear speed in inches per minute. Now I asked for it in feet per second and in miles per hour. So all we have to do is take this answer and do double unit conversions on it to get those 2 other units. So step 2 here is to convert. We take our 75,360 inches per 1 minute, and we have to do a double unit conversion. So you set up 2 conversion factors, or 2 conversion ratios, and we'll handle the distance in this one right here, and we'll handle the time in this one right here. So inches are up top here, so they must be on the bottom for our conversion. We're converting those inches to feet. And since minutes are down bottom here, they go up top, converting those minutes to seconds. Put the units in place, and then the numbers fall with their proper units. 12 inches in a foot, 1 minute, you have 60 seconds. So in this case, all you have up top is 75,360 times 1 times 1, which is going to give you that 75,360. Then on bottom, 1 times 12 times 60. You get a number there, do the division, you should end up with 104.67 as the number. And now notice minutes cancel out, inches cancel out, so that's feet per second. So here is our answer. That same 75,360 inches per minute in terms of feet per second would be 104.67. Now, I also asked for the same answer in miles per hour. So for that, we have 2 options. We can either take this answer and convert it to miles per hour, or we can take this answer and convert it to miles per hour. Should end up with the same answer. However, there's a better choice. You want to use a less calculated information if at all possible. We can't use all givens because naturally we calculated this. But if we made a mistake calculating this and we use it to calculate something else, that's called a compound error. So we'll go back to our 75,360 inches per minute, and now we want to convert it to miles per hour. Inches are up top here, so they go on the bottom, converting those inches to miles. So miles go up top. Minutes are down bottom here, so they go up top, converting those minutes to hours. You may not know this off the top of your head, but there are 63,360 inches in 1 mile. If you're not sure, you know there's 12 inches in a foot, 5,280 inches in a mile. 12 times 5280 will give you that 63,360. And we know 60 minutes in an hour. So you take our 75,360 times 60 and take that divided by 63,360, you end up with 71.36. Inches cancel out, minutes cancel out. You're left with miles over hours, or what we like to say, miles per hour. Now, oftentimes people write miles per hour as mph. You'll see that in the next example, in the next video. I don't want you necessarily to write it like this unless it's your end answer. I'd rather you write it like this to show that it is a ratio that miles are up top over hours. in this case is 71.36 miles over or per 1 hour. But that's how you find linear speed given angular speed and radius.